All right. So I guess last question then is, where do you see this going in the future? What is the final vision for how all this ought to be incorporated into our clients' environments?
What I'd like to see, which we're not there yet, is the understanding from the clients that you actually need to start thinking about a twin at the very beginning of the thought process. So we have to instantiate what I would call a virtual twin because everything would be model based because the thing I want to create doesn't exist yet. In that sense, I'm creating models to represent the behavior I want to build. And then as that model matures and as the components and manufacturing starts to catch up, that virtual twin becomes a digital twin because now I can represent that in the physical world. So what that means is from the very beginning, I need to tell vendors you need to have a digital twin construct to help us do trade studies, to help us understand what the interfaces need to be before I start bending metal manufacturing, so that I can save money on my reduction activities by doing all those trades synthetically. Then when I start bending metal, I can go much faster because I already know what I'm going to build. Already know what it's supposed to look like because I've digitized all of that already.
Okay, so there's a couple things that you just mentioned. So number one, it's going to take partnership with some of the OEM vendors. When you want each of the OEM vendors should have a digital twin representation as part of the thing that they sell.
Yes.
I think that's fair and that makes sense. And as this gets more traction, we're going to get more help from that side of the fence. But you also mentioned using this as sort of like a development environment. Well, our customers are supposed to be creating development environments anyway, right? I don't always test, but when I test, it's in production, right? So we should be having testing environments anyhow. So what you're really talking about doing is sort of repurposing the dollars that you would use to create a bespoke test environment and use it to create a reusable twinning environment where you could generate as many test environments as you want to and any of the other future use cases. So we're talking about repurposing dollars that exist with just a little bit of vision. Is that what I just heard?
Yes. Yeah. And so having both the OEMs as well as the clients appreciate the value that that would bring to them from their investment, would enable them to actually be much more foundationally to grow in different and exponential ways.
Okay, but
Because
I asked the question. I said it was going to be my last question, but now I've got another follow-up here, right? If the OEM vendors don't provide digital twins, are we stuck? Are we in a chicken and egg problem?
so it depends on the level of fidelity we can achieve without their help. If you can achieve many of the behaviors that the client cares about, then you don't need the physical hardware. But there are some instances where you do need access, a physical access to that hardware, whether it be, through our own internal testing of that thing or the vendor partnership to allow us not to understand how it's designed, right? Understanding how it functions and creating sensors like IoT sensors to feed the data from the different ports so that we can create models around those in the digital twin to represent how those things physically operate, even if we don't know what the design is.
Okay, so fair enough. So, best if the vendors can do it, but then we have the ability to sort of fake the funk using existing things that are out there, either patching in actual pieces of hardware or creating our own emulations of things that to some level of fidelity. So we are not stuck if the vendor asset isn't there yet.
Correct. And actually,
Okay.
those are the conversations we're having today with, like, for example, the Air Force on the Blue 53 contract. They want us to emulate a radar warning receiver or a harm sensor on avionics, system. But we don't have access to the manufacturer OEM specs, right? But they have the physical lab hardware already available to us. So the pitch was we can actually make use of that laboratory hardware as hardware in the loop and start developing models of all those internal elements. And then you have a digital representation of the actual thing to do further risk reduction as well as interface testing with other platforms.
Fantastic. That sounds very, very cool. Thank you, Stephen, for the time. This is a super fascinating conversation. I look forward to having some more with you.
For more information, visit mantech.com/expertise/intelligent-engineering.